All right, so the next thing on our list is to look at statistical measures. So we've been kind of bopping back and forth between quantitative analysis, categorical analysis with our bar charts, and now we're back to quantitative analysis. You know, the Khan Academy is continuing to just look at quantitative and all the different ways you can analyze a bunch of numbers. But for our graphing, we're back to quantitative after doing 1 week of bar charts for categorical. So the statistical measures is really pretty straightforward for the coding. I just want to take a moment to look over the numbers that we get. So when we run this function called describe and create a variable that has the value, the output for this function describe, that we then go ahead and print right after it, what you get is a bunch of numbers, but they're all describing that data set. So, you know, my diagnosis age variable, there were 783 people that we even asked whether they were diagnosed with asthma. The average or mean was 11.98 years old. The standard deviation, which we're going over somewhat in Khan, but I'll repeat, basically measures how spread out it is. And what it's doing is it's taking each individual of these 783 data points and measuring how far it is from this average 11.98. And it averages those distances. So the formula for it is a little bit convoluted, but luckily Python does it all for us. But it basically is saying on average, these values are about 8 away from 12. So you might get some that are more than 8 away. You know, people were older than 20, and you might get less than 8 away. Sorry, more than 8 away on the other side, my bad. More than 8 years away on the other side, so younger than 4 years old. But on average, you've got 8.36 years away from this thing that's about 12. So these others are quartiles. And so what they're doing is they're breaking up all these 783 numbers, listing them in order, and saying, well, the very minimum number is 0, those 0-year-olds, that the babies that are getting diagnosed. A quarter of the data, or 25% of the data, is younger than or equal to 5 years old. Half the data is younger than or equal to 11 years old. So the 50th percentile, half of all these 783 numbers are 11 or smaller. And then 75% of the data is younger than 18 years old, and the max age here where they were diagnosed was 32 years old, so 100% of the data is less than 32. So we're going to talk about percentiles a little bit more in the next week, but that's just a summary a bit of what these numbers are measuring. Okay, so to go into the Python, the big function is this .describe. So let me go into the program, get a new code block, and as you can see, I've run it recently, so it should all be there. Everything that I've done, all the data management that I've done for my quantitative variables. But so I'm going to go. So this is for the diagnosis age variable. So let me go ahead and copy that. And I'll say that description for the diagnosis age. You can write that any way you want, but there's a nice variable name that helps me remember what it is I'm doing. So the description for the diagnosis age is this diagnosis age, and then the describe function. So I'll run that. And now all I have to do is print description for the diagnosis age. And it'll give me that output. And And there we go. And here's the same numbers that were already on the slide. So easy peasy. It's a two-liner. This one is just, you can print really anything that you've got going on. You can print it, a string, something in quotes. I've made a variable that is the output for this describe function. So anyway, I'm going to do the same thing for sibling number. And so we'll do the description for sibling number equals, I should make sure that I have the right variable name for sibling number. There it is. Sibling number. And then we'll print that. And there you go. All right, everybody, take care. See you next time.